Hello, in our last class, we have introduced the difference between a microstate and a macrostate. Then we have discussed how a thermodynamical parameter called entropy is related with the number of microstates. And we have also studied the contact between statistics and thermodynamics through an example where you have two macrostates with different NV and E, and these two macrostates are in thermal contact where N and V remains unchanged. And there you have found out that the energy transfer will continue until beta of the respective of all systems, all macrostates become the same. So that was last day's class. Now in this class we will study further contact between statistics and thermodynamics. Okay. Okay, now earlier case we had two subsystems A and B where the wall was thermally conducting, right? Thermally conducting. Now we will elaborate this argument further by taking another case along with the first case, which is the wall is thermally conducting as well as movable. Okay, the wall is not penetrable, so N1 and N2 will remain intact. But in the second case, V1 as well as E1, that is V and E are changing. Okay, here the wall is conducting as well as it is movable, right? So for the composite system V0, V1 plus V2 will remain a constant, but V1 and V2 in itself will change, right? V1 as well as V2 are variable, right? But V0 of the composite system will remains, this whole volume will remains the same, right? Now that is our second case. Okay, in our earlier case we have at first deduced what was omega. Okay, here also we are doing that. Omega of the composite system is depending upon V1, V2, E1 and E2 obviously, right? And that would be equal to omega 0, V0, E0, V1 and E1. Why it is like that? Because E is a constant and that is equal to E1 plus E2, right? So since E is a constant, E2 is related to E1. Okay, so you have, instead of two variables, you will have just one variable E1 and a constant E0. In the second case, you have V0 equal to V1 plus V2. Here V0 is a constant, that means V2 is related to V1. So omega is dependent upon V1 as well as V0. That is what that is written here. Okay, so that can be written as omega 1 V1 E1 into omega 2 V2 E2, just like in the first case where you just had E1 and E2. Here, along with E1, you will have V1 as well as V2. Okay, so in the first case, when the wall was just thermally conducting, you got this equation, which was this one, right? This is the equation for beta, and the macro states will conduct until betas becomes same, right? Beta 1 equal to beta 2 equal to beta 3 equal to, just like that. Okay, now just like in the first case, our volume equation will also vary just like this, because instead of E1 and E2, you just have V1 and V2, and all the procedures, mathematical procedures, are same. So eventually you will get a similar equation just like that. So instead of E, you will have V, right? So this is your second equation, which is this one. Okay, now here you can see that instead of E1, what you have is V1, omega 1 is omega 1, N1, V1 is treated as constants in the first case. In the second case, N1 and E1 is treated as the constants, right? It won't change. Why E1 is changing, right? But in here, since E and V are independent quantities, we can variably separate these equations, and you can write, in the first case energy is changing, in the second case volume is varying. Okay, so you will have same equation as in the case of first one, and you will have this equation just like in the first case. Okay, so instead of beta, you will call this equation as eta. Okay, so eta എന്ന് പറയുന്നത് dou by dou v1 ln omega at equilibrium volume equal to dou v2 ln omega at equilibrium v2, right? അപ്പം ഒരുപാട് മാക്രോ സ്റ്റേറ്റുകൾ ഉണ്ടെങ്കിൽ you will have dou vn into log ln omega n at equilibrium volume. So volume will change until this equation becomes same for all macro states. Okay, so now if you can elaborate this argument more, then you can say that uh, the wall is thermally conducting, it is movable, and in the third case it is penetrable. Penetrable means what? Atoms can move through the walls. That means the wall is porous. Okay, that means the wall is porous. Okay, in that case also you will have three equations. First one is for equilibrium betas has to be same. For equilibrium etas has to be same. In this case, for equilibrium psi, this is psi. Psi has to be the same. So it is the same equation, just in the case of first and second, just like in the case of first and second. And instead of v, you will have n, and instead of equilibrium, instead of n, you will have equilibrium n, where v and e are treated as constants. Okay, so you will have three different equations, and equilibrium is attained when beta, eta, and psi are the same for all macrostates. Now, with the help of this equation from Boltzmann, that is S equal to k ln omega, And the first law of thermodynamics, that is dE is equal to T ds minus P dV plus mu dN, where mu is the chemical potential. Now you can differentiate partially this equation under some conditions. Let us say that N and V are constants, then this term will be cancelled and this term will be cancelled, and you will get dou S by dou E at constant N and V equal to T will come here, and that will give you 1 by T, right? Similarly, at other condition where you have constant N and E, then this will be cancelled and this will be cancelled, right? Then you will have relation between ds and dv, which is exactly given here at constant n and v. You will get p by t, right? These two constants will come out, and you will get a fraction of p by t, right? So similarly at constant v and e, that means this one will not come in the equation and this one will be cancelled. Then you will have a relation between s and n. So dou s and dou n, dou s by dou n at constant v by e is equal to mu by t. Pretty obvious from this equation, right? Now at first what we are going to do is, actually we have already done this. We are actually finding out what beta is, right? Now we have done this, what beta is. Okay, so in our earlier classes we had this equation in our earlier classes, which was delta s by delta ln omega is equal to 1 by beta t, and this 1 by beta t is a constant, and that constant is k, which is the Boltzmann constant, right? Now you had this Planck equation, which is s equal to k ln omega, and this 1 by beta t is instead of this k, right? So 1 by beta t is nothing but Boltzmann constant, so that means beta is equal to 1 by kt, right? That's a pretty simple equation. Now we need to find out what is eta and what is uh, psi, right? In terms of thermodynamic parameters. Okay, for that we are going to write the equation for eta, which is dou by dou v ln omega, right? Now this will be equal to 1 by k into dou s by dou v. How I am going to get this? I will get this by chain rule. I can write this as dou by dou v. Instead of dou v, I can write this as dou by dou s into ln omega at constant n and e into what? Dou s by dou v at constant n and e, right? Now what is dou s by dou v at constant n and e? It is this one, p by t. So this can be this can be rewritten as p by t. And what is dou by dou s of ln omega? And you know that k ln omega is s itself. K ln omega is s itself. So I can put 1 by k here, and dou by dou s of k ln omega is nothing but 1. So my equation will be 1 by k into what? Dou s by dou v, which is p by t, right? So eta is equal to p by kt, right? And similar approach, you can find out psi, which happens to be mu by kt with a minus sign. Okay, same equation. You have psi is equal to what? Psi is equal to dou by dou n of ln omega. Okay, now you can change this with chain rule. This n can be shifted with s. So dou by dou s into dou s by dou n, that you have already have this equation, right? So what you get is minus mu by kt by similar approach. So in principle you have three relations with beta is equal to 1 by kt, eta equal to p by kt, and psi is equal to minus mu by kt. So we have defined beta, eta and psi. If the wall is thermally conducting, energy flow will continue till betas becomes the same. That means from the equation of beta you can assume that the energy transfer will continue till the temperature will be the same in every microstrate, right? So this was as expected, and this is according to our general knowledge of thermodynamics, right? Now if the wall is thermally conducting and movable wall, equilibrium will be reached when T1 will be equal to T2. That is what we explained before. And from here you can see that if the wall is movable, then the volume will be the equilibrium volume will be settled when P, you can see here, P becomes same in each compartment. The pressure becomes same in each compartment. So if it is thermally conducting and movable wall, then P1 should be equal to P2. Then you will have equilibrium volume for both compartments in our earlier case, and T1 has to be equal to T2. Till then the energy will flow, right? Now if you have a thermally conducting wall and a porous wall, I'll write this as porous wall. What is porous? Porous means particles can be exchanged. Then if it is thermally conducting, equilibrium will be reached when T1 equal to T2, and if it is porous wall, the particle will go from one compartment to another till the chemical potential become same. Okay. Now in general, if you have your wall has to be, if your wall is thermally conducting, flexible, as well as porous, then all these three conditions has to be satisfied to be in equilibrium. That is, beta 1 should be equal to beta 2 should be equal to beta 3 and so on, just like your temperature. Okay. And here eta 1 should be equal to eta 2 and so on, which implies pressure has to be same in each compartment. If the number of particles are exchanged, then psi 1 should be equal to psi 2, which implies the chemical potential has to be same in all macrostates. Now let us derive the thermodynamical relations from a statistical beginning. Okay, so the question here is we have the first law of thermodynamics, this one, which is this one, and from here you can partially differentiate and get many equations, right? Just like what we have done in the first part of this lecture, right? Now our question is whether same equations can be obtained using a statistical beginning. That means you know that statistically S is equal to k ln omega. From this equation, can we reach the equation that is obtained from the first law of thermodynamics? That is the question. So you start with S is equal to k ln omega. Now what you are going to do is you just differentiate s with respect to e. Let us say at constant n and v. Since you know that s is a function of n, v and e, right? So dou by dou e of s is what? K, ln omega. K can be taken out. Then what you have is k into dou ln omega by dou e, right? Which is nothing but beta. That is exactly given here. Dou s by dou e is k beta. And what is beta? Beta is 1 by kt, and that will yield you 1 by t as dou s by dou e at constant n and v, right? Similarly, you can differentiate instead of e, you can differentiate it with v, and you can yield k eta, which is p by t according to these equations, right? Similarly, dou s by instead of e, you can put n, right? Then you will get k psi, and that would be minus mu by t according to this equation, right? Now, you have this equation. Now what you are going to do is you are going to divide equation 2 with equation 1, equation 2 with equation 1. Then p by t divided by 1 by t will give you p, which is the pressure, and the LHS of this equation is dou s by dou v at ne and dou s by dou e at nv. So such a division cannot be easily done. So you have to use a mathematical argument here, a mathematical identity here. Let us say that you have a function of x, y, z and t equal to 0. So what is the logic of such a function? In here, x is s, y is v, z is e and t is n. Well, n is constant in both cases. So you have t, which is a constant. Then you have this cyclic differential, and that would be the multiplication of this cyclic differential will be equal to minus 1, right? So the first case, f of x, y, z and t equal to 0 is substantiated because s is a function of n, v and e. So s is equal to a function of n, v and e. So s minus a function of n, v and e is equal to 0. That means a function of s, n, v and e is equal to 0. So you can use this equation here, and this is similar to, you have two things, p is equal to dou s by dou v into dou e by dou s. You just invert this equation, and this is exactly same as the first part of this equation. That means this part has to come here, which is exactly given here. Okay, so p is equal to minus dou e by dou v. Now, is this the equation which we get from the thermodynamical equation that we have to find out? You have P here. Now what you are going to do is you just differentiate at constant n and s. At constant n and s means this term will get cancelled and this term will get cancelled, right? Dou E by dou V minus equal to P, which is the equation exactly given by thermodynamics. Dou E by dou S equal to what? Minus P, or minus dou E by dou S equal to P, which is exactly the same which we obtained from thermodynamical approach as well as the statistical approach. Similarly, mu can be found out using uh, these two equations, equation 3 and equation 1. You just divide it just like in the case of first one, and you will get dou E by dou N, and that is at constant V and S. So at constant V, this term will be cancelled in thermodynamic equation. At constant S, this term will get cancelled. So dou E by dou N is equal to mu. Mu is equal to dou E by dou N, right? So, and T, obviously T is what? T is, this is 1 by T is dou E by dou S by dou E, and T will be dou E by dou S at constant N and V, right? So that's the exact result which we get from statistical thermodynamics, and this shows the validity of statistical mechanics, and using statistical mechanics you can reach the thermodynamical parameters very easily. Similarly, you can find out other thermodynamical relations like specific heat at constant volume Cv, that is equal to dq by dou q by dou t, right? And what is dou q? It is nothing but dou ds by dou t, right? So t, dou s by dou t, and t is what? T is dou e by dou s. So you can easily cancel dou s from here and dou s from here. And what you get is dou e by dou t at constant and v. So Cv is equal to t dou s by dou t at constant and v, and t is dou e by dou s at constant and v into dou s by dou t at constant and v. Dou s and dou s will get cancelled, and you will get Cv is equal to specific heat at constant volume equal to dE by dt at constant NV. Similarly, Cp എന്ന് പറയുന്നത് നമുക്കറിയാം എന്താണ് T into dou s by dou t at constant NMP ആണ്. എന്ന് വെച്ചിട്ടുണ്ടെങ്കിൽ ഡോ ക്യൂ ബൈ ഡോ ടിക്ക് പകരം ഡോ എൻതാൽപി ബൈ ഡോ ടി എന്ന് വരും. സോ സി പി ഈസ് ഈക്വൽ ടു ഡോ എച്ച് ബൈ ഡോ ടി കോൺസ്റ്റന്റ് എൻ എം പി എന്ന് വരും അല്ലേ. അപ്പം സി വി എന്ന് പറയുന്നത് സി വി ഈക്വൽ ടു ഡോ ക്യൂ ബൈ ഡോ ടി ആണെങ്കിൽ സി പി എന്ന് പറയുന്നത് ഡോ എച്ച് പ്ലസ് ഡോ ടി ആണ്. എച്ച് എന്ന് പറയുന്നത് ഇ പ്ലസ് പി വി ആണ്. ഇ പ്ലസ് പി വി ആണ്. ഇ പ്ലസ് പി വി അല്ലേ, അതാണ് ഇവിടെ ഉള്ളത്. സോ ദിസ് ക്യാൻ ബി ഡോ ബൈ ഡോ ടി ഇ പ്ലസ് പി വി കോൺസ്റ്റന്റ് എൻ എം പി. അപ്പോൾ ഇതുവരെ പറഞ്ഞത് എന്താന്ന് വെച്ചിട്ടുണ്ടെങ്കിൽ നമ്മൾ എസ് എന്നുള്ള ഇക്വേഷൻ കണ്ടുപിടിച്ചു. എസ് കണ്ടുപിടിച്ചതിൻ്റെ ശേഷം അല്ലെങ്കിൽ അതിനോടൊപ്പം തന്നെ ബീറ്റയും ഈറ്റയും സൈയും എന്താന്ന് കണ്ടുപിടിച്ചു. അതെല്ലാം കൂടി കൂടിയിട്ട് നമ്മൾ പണ്ട് നമ്മൾ കണ്ടുപിടിച്ച തെർമോഡൈനാമിക്കൽ റിലേഷൻസിലേക്ക് എസ് കെ എൻ ഒമേഗ വെച്ചിട്ട് എത്താൻ കഴിയുന്നുണ്ടോ എന്നാണ് ഇപ്പം നോക്കിയത്. ആൻസർ എത്താൻ കഴിയുന്നു എന്നുള്ളതാണ്.